I have decided to actually explain the quiz. So I'll just explain basic ideas and concepts and the questions that are like number 6 and number 14 and 15, so the calculating questions. Oh, I forgot to do 13. Okay, I will explain those at the end of the video. Like, I'll have like a separate video thing that I'll just edit in the end, because I can't really write on this one. So question 1, which of the following are always conserved in a nuclear reaction? Could just memorize charge and number of nucleons. What am I supposed to explain? Just memorize this. Okay, half mv squared, kinetic energy. We've been doing this since 8th grade. So it's the speed, kinetic energy. Which of the following is expressed as mgh? Again, we've done this, gravitational potential energy. So m is mass, g is gravitational acceleration, h is height. The energy needed to separate two hydrogen nuclei apart is called bond energy. Just memorize that bond energy is basically like the separation and like the joining, the energy needed to join and separate each atom. Select the symbol that refers to an alpha particle. So at the end of the sheet right here, you will see a table which you will have to memorize. So the protons, electrons, positrons, neutrons, alpha particles, the charge, the mass, the number of protons, number of neutrons, you'll have to memorize, as well as the actual particle thingy, like the symbol and stuff. Okay, so memorize that. Same with number 5, you'll have to memorize the table at the bottom. This is at the end of the video. Consider the following reactions. Choose a letter that refers to a nuclear fission. Fission. Reacts from the list. So nuclear fission is like, it's a split of the nucleus in the atom, right, into two smaller nuclei. So from 1 to 2, it splits from 1 to 2. So it's the B is the only one that has one like nucleus of an element. So neutrons don't count because they're neutrons, so they're not actually an element, but see uranium, barium, and chromium. It's chromium, right? Like it splits into 2. So from 1 to 2. Choose the correct answer to complete the following sentence. At a certain distance, the two hydrogen nuclei have the lowest potential energy when the net attractive forces are equal to the net repulsive forces. Again, memorize this. It's like kind of like a law. Like you have to like memorize it. So think like this. Like when two hydrogen nuclei. So there's a hydrogen atom. It has a nucleus, and it has protons and nucleons, whatever, in the nuclei. And it has the electrical field around it with the electrons. So when they come closer to each other, so the positive and the negative charges like become like repelling at a certain distance, like they repel each other. But at the same time, like at a certain distance, it also like attracts each other, because like positive, negative, and then the negative and negative repel against each other. So at a certain distance, when they're literally like the distance is like equal to each other from like I have no idea how to explain this. Just when two fields like cross together, there's like a certain point, like a certain distance where they don't go closer and they don't like move farther away. So they're just there. So they're bonded together. Covalent bonding. Choose the correct answer to complete the sentence below. So E equals mc squared. You know, it's Albert Einstein's famous equation. You can see it in every single picture on Google when you search up science. I'm not sure if this week's CA will have, like, when we actually have to use E equals mc squared, but, because it's not in a quiz, but it could be, like, in the exam. So just remember that E is the energy, M is the mass, and C is the speed of light in vacuum. Ignore that. Speed of light is 3 times 10 to the power of 8 meters per second. Yeah, usually either energy or mass is given, and speed of light is always given, right? So you'll have to find either E or M. Choose the correct answer to complete the following sentence. Change in heat is delta heat. That's obvious, just memorize that. Refers to the difference between heat content of products and the heat content of reactants. So this is Hess's law, right? So unlike the bond energy, which is heat of reactants minus heat of products, this is Hess's law, and it's heat of products minus heat of reactants. So it's essentially like the same but a bit different thing. Number 11 is just the Hess's law, memorize the whole sentence, not just the blanks. I have done this mistake many times, just memorizing the blanks, and then, like, instead of path followed, like, the blank would be heat evolved, and I wouldn't know that. Just memorize the whole sentence. It's like, what, 2 lines? Just memorize this. Number 12, a group of students were asked to measure the amount of heat generated during a reaction. How should they go with the experimental procedure? They should measure the change in temperature inside a bomb calorimeter in which the volume of the system remains constant. Again, everything is explained. I can't do anything but just read what I explained before this. Bomb calorimeter is used to, like, measure the heat energy and, like, the energy content of a substance. Again, everything is just said right there. Volume has to be constant at all times because, like, if you change the volume, then the heat change is not accurate, you know? It's like, I'm not gonna go into this, like, too much, I'm not gonna confuse you, but, like, it has to be constant so it doesn't change the output or anything. So we know that it's just the heat change and nothing else, like, influencing the changes and stuff. 13, explain at the end of the video. 14 and 15 also explain. Calorimeter is the measurement of reaction heat. Just memorize. And memorize this table, it's important. I'm done. This will take a while to explain. So, the given, to change the temperature of a particular calorimeter. So we see calorimeter, so we immediately think of delta H equals to, change the color of that, equals to, oh, okay, I'll just remove this. So I wrote this on one of the bloopers, so ignore the bad handwriting. So it's negative Q over N, that is a Q, if you cannot, like, notice that. Okay, whatever. So first we have to find the number of moles, right? So they're given that the complete combustion of 8 grams of methane gas. So we do mass over molar mass, or we do the cross multiplication, whatever you see fit. So we find the mass of methane before. It's like 1 mole of methane, which is right here. So we do 12 plus 4, which is just 16. So 16 grams of methane gives out 1 mole. How much is 8 grams? Cross multiply, you get 0.5, so it's half a mole. So we found our N, which is 0.5. Now we have to find our Q. It could be negative Q or Q. It does not matter, since right here it says find the heat of combustion, and combustion is an exothermic reaction, and since it's exothermic, we add a negative sign at the end anyways. So it doesn't really matter. So the answer is going to be the same regardless. Okay, now to find our Q. Q is the heat released by the combustion. So it's given 2.5 degrees Celsius, and every 1 degree Celsius requires 10 kilojoules, right? So logically saying, we have to multiply them, right? So if 1 degree Celsius gives out 10 kilojoules, then 10 gives out 20 kilojoules, so 2.5 gives out 25 kilojoules, my bad. So you just multiply those two together. So your Q is 25. Okay, that was a major fail. 25 over 0.5. And when you divide those two together, you get 50. How do I draw that equal? Okay. 50. God, I apologize for this. My iPad's not charged, and this is the closest thing it had to me. So you get 50. Since it's combustion, you add a negative since it's exothermic. So your answer is negative 50. If you just do negative 25 times 0.5, you still get negative 50. Okay, this question's a bit confusing. This is Hess's law. This is how you solve this question with Hess's law. It's question 13 in your quiz. Nitrogen dioxide, NO2, is one of the gases that cause acid rain. That's just like, it's a filler thing. Just memorize it just in case, like that line. I don't know why, but I have a feeling it'll come in a final or periodic or IG if you're taking IG chemistry. Nitrogen dioxide can be produced by the following series of reactions. So these reactions right there, let me just open that. These reactions are the given. So this question might come in the written part as well as number 14 and 15. These questions might come in the written part. So right here in the brackets is the given. They will always give you this. They're either going to give you the given, these two like equations right here, or they're going to give you a table with a bunch of equations, and you'll have to find them. You'll have to like choose which ones make this equation. So we're going to use these two equations, they're given, to make this equation, right? This is also given. But this is what like it's supposed to look like. The answer is positive 91.5 kilojoules. How do we get that? Okay, first let's look at nitrogen oxide, NO. So which equation out of the two has NO on this side? So on the left side of the equation, so like the reactant side. So it's the second one, right? So we write this equation. I'm not going to write it right now, but okay, I'll just write it like, I'll just make a line in black right here. So that's the second equation. And the heat change is negative 122 kilojoules. Okay, moving on. So we have half of oxygen dioxide. Oxygen gas. I don't know, I just glitched right there, my bad. So which equation has oxygen on the left side again, on the reactant side? None of them. So we can use the first equation, which has oxygen on the right side, on the product side, and we basically just flip this equation, right? So I'll change the color right here, pink. Okay, so the pink equation right here, we flip it. So we get somewhere right here, I wrote it. So after we flip it, we get 302 into 203 right here. So we put it underneath this equation. Okay, and since we flip it, the heat change right here, which is negative 427, we make it positive 427 since we flipped it. Right here. It says so right here. After we do that, so now we have to like cancel to make this equation, right? So just like any normal canceling, we have to balance before we cancel, right? So to balance it, so we look at NO and we look at NO in the equation right here. It's the exact same, so we just leave it, so we can just cross it out, right? And we cross it out and we put NO. Next, we have to think of the oxygen, and since we got 3O2 and we only need half O2, we look at any other equation that has oxygen, O2, oxygen gas. We have one right here, which is just 1. But if we do 3 minus 1, we get 2 and not half of O2. So what we do right here in this equation, we divide it by 3 or 2. You have to it's trial and error. You can either divide it by 2 or divide it by 3, and in the end, the correct answer will have to balance it out. So we can try by dividing by 3 first. So if we divide it by 3, this is going to be just O2, and this is going to be 2 over 3O3, right? again, this won't work because you only have one O2 here and then one O2 on the other side. So if you write it down, you're going to see that it's just 1, 1. And since it's 1, 1, it's just going to cancel each other, and O2 will not exist in the equation. So then we try the next step, which is dividing it by 2 instead of 3. So when we divide it by 2, we cancel the O3, so we don't have the O3 anymore. And this will become 3 over 2. 3 over 2, in other words, is 1.5. So when we do 1.5 minus the 1 from the other side, so we do 1.5 minus the second equation right here, you see 1. So it's 1.5 minus 1, and you get 0.5, which is a half. So you get 1 over 2 O2. This is really confusing, my bad, guys, but unless you write it down, it's going to be very, very confusing. Okay, we have O2, and the 2O3 here and the 2O3 here cancel each other out. So once you divide those two, like by 2 here, you're going to get 1O2, 1O3, and 1O3 here. And since it's flipped, it's on 2 different sides, so we subtract those. So we cancel those 2 out. And then we see NO2 right here. Again, there's nothing to cancel it with, so we just put it here. After you're done with that, you just add the heat changes. So you do negative 122 kilojoules plus this, and it's positive, so it's positive 427. But since we divided the whole equation by 2, we divide this by 2 also. So we get 427 divided by 2, which is 213 and a half, so 213.5. So it's plus 213 and a half right here, and you just get positive 91.5 kilojoules. That's it. That was tricky. I'm sorry, guys. That was so bad. Ignore that, please. Okay, bye-bye. Explain. Everything else in the quiz is like memorization and like general information stuff that you're supposed to know from class, but if no, you can just memorize it from the quiz or memorize it from the sheet. It does not matter, since it's probably going to come the same in the actual exam. Okay, so calculate the wow, I just glitched there. Okay, the heat change in kilojoules per mole of the reaction between ethene and chlorine Cl2, given the bond energy values in the table below. Okay, so this is pretty self-explanatory. So bond energy formula is the, I forgot to select the thing. It is the heat. Oh my god, this is this is heat of reactants. So this part, so the heat of this part minus the heat of products. If it decides to work, heat of products. So minus the heat of this. So to know the heat, they give you this table right here of the energy in kilojoule per mole. So we just basically add them up, whatever we see, and then we minus them. So here you can see that, so it's C to C, so carbon to carbon right here is 602. So you do 602, so 602 plus, and we see C2, so carbon to hydrogen, 1, 2, 3, 4 times. So we look at carbon to hydrogen right here. So it's 602 plus 413, so 413 times 4, since there's 4 of them, times, just make this clear, times 4. So after you do that, you're supposed to get 2254, as right here, set that, so you get 2254 plus 240, which is just chlorine to chlorine right here. So chlorine to chlorine is 240, so it's 2254 plus 240. Now we move on to the product side. Carbon to carbon, that's 346, so you do 346 plus carbon to chlorine twice. So there's 1, 2. So it's carbon to chloride. So it's 327 times 2 added to the 3, 4, 6. And then you see again the carbon to hydrogen 1, 2, 3, 4 times. So you add those two. You multiply those and you add it to these. So it's plus 413 times 4 again. Times 4. After you add them all together, you get 2652. And you do reactants, which you get after you add these two together, you get 2494. Pretty sure. Yeah. So you get 2494 minus the products, which is 2652. And after you subtract those two, you get negative 158. And extra information or whatever, you can, if it comes in a written part in a periodic, and they'll tell you to explain it or what kind of reaction this is. You can see that it's negative 158 kilojoules per mole. So the heat change is negative. So that means that the reaction is exothermic and it could be a combustion reaction since it's negative. Okay, this is actually really weird. Explanations. Fun. Okay, for number 6, what is there? So basically, these two added up together. Oh, by the way, I'm sorry, I'm on my MacBook, and oh, okay, that was not supposed to happen. How do I fix that? Okay, these two added together is supposed to be equal to these added together. It's all of that. So this is 236. Okay, that looks so sad. That's 236. So all of this is supposed to be equal to 236, right? But if you add them up together, oh, by the way, this is the answer. So we have to find this right here. So in the given, we are given 147 plus 86, and you only get 233. So this is equal to 2, oh, that looks like a penis. Okay, 233. Write this. This thing is equal to 233. Now, to find the missing element, we have to add the charges to find out the charge of the element. So this charge right here is supposed to be equal to this charge, all of this charge right here. So we do 92 plus 0, which is still 92. So the charge of the product is supposed to be 92. So we do 59 plus 33, and the charge is 92. So that means the charge of the missing element is 0. So the only thing that has 0 charge is a neutron, which is the hidden element. And the mass of the neutron is 1 AMU. But we need 3 AMU, so we need 3 neutrons, ergo we put the 3 right here.